If you're interested in growing microgreens, an important place to start is by answering the question, what are microgreens? So in this video, we're going to take a look at 1. The general characteristics of microgreens, 2. Microgreens seed germination, 3. The differences and similarities between microgreens and sprouts, and 4. We're just going to add a quick note on regulations as they relate to microgreens. So at a basic level, we define microgreens as the young, edible shoots of vegetables, flowers, herbs, and grains growing on a rooting medium on a 7 to 12-day cycle. But to better understand microgreens, I find it useful to highlight their overall characteristics. So let's look at those now. First, microgreens are grown vertically in soil or another rooting medium such as hemp or bamboo mats. Many commercial and home growers achieve this by using a 10-inch by 20-inch plastic tray called a 1020 tray to grow their microgreens. But there are other size trays or troughs you can use as well, and we'll talk more about trays in future videos. Microgreens are typically grown on short cycles ranging from 7 to 10 or 12 days, but sometimes as long as 30 days or more. We're going to mostly focus on the shorter cycle crops of 15 days or less, but we will touch on longer cycle crops later. Microgreens go through 2 to 4 stages of growth. First is the seed soaking stage, which induces germination in seeds. This is usually just used for larger seeds like pea, sunflower, wheatgrass, and corn, but can also be useful for inducing germination in some smaller seeded crops like beets, chards, or cilantro. Then there's the germination stage, which usually occurs in the dark and with the seeds under weight or pressure, usually by placing a heavy brick or paver over a tray of germinating seeds. Some growers then use a blackout period, an optional stage that follows germination where the crop is kept in the dark but without the weight applied. And the final stage in the growing process is the light or photosynthesis stage, which powers sugar production in plants and turns the crop green, or red as the case may sometimes be. Microgreens measure 2 to 8 inches in height at maturity, depending on the crop. At harvest time, microgreens are cut at the base of the stem, or hypocotyl, separating the roots from the edible shoots. Microgreens are typically harvested before true leaves form, which we'll talk about more here in a moment. Microgreens have a very high nutritional value, which makes them a very desirable consumer product. And they typically have a post-harvest storage life of 7 to 14 days, depending on the crop. So now that you're more familiar with the key characteristics of microgreens, let's take a quick look at microgreen seed germination. As I just mentioned, microgreens are typically harvested before the true leaves form. This means you are eating a short stem, called the hypocotyl, and the first set of leaves, called the cotyledons or seed leaves, because they actually are the seed. So let's take a look at a germinating microgreen seed to get a better sense of what this terminology means and to get a little bit of a deeper look at what the microgreens crop cycle looks like. And this is really easily observed with sunflower seeds. So a sunflower seed, like most seeds, basically has 2 main parts. First, there's the durable outer part, which we call a shell, a husk, or a hull. And then there's the inside part, which is the actual seed that will germinate. And the seed has energy stored in it to power the germination process. Here we can see the earliest stage of germination in sunflower, where the radicle, the first emergent of the roots, is just protruding from the hull. At this stage, the seed is still lying flat on the soil, yet it's starting in its transformation into a set of leaves. This is the germination stage, where the seeds are typically under weight or pressure. Here are the seeds after about 2 to 3 days in the germination stage, with the radicle now well anchored into the soil and starting to push the transforming seed upward in an effort to reach the light. Germinating seeds can easily push up the weight on top of them. A tray of sunflower seeds like this can easily push up 30 pounds of weight as it germinates. It's very impressive. After 3 to 5 days, depending on the temperature, the stem, or hypocotyl, is well elongated, and the now transformed seed starts to open up as the first set of leaves. This is a sign that the germination stage has come to an end. Here you can see in the front some leaves that are fully opened and turning green as they have been exposed to the light, and others which are still yellow as they have yet to see direct light and start photosynthesizing. As the seed expands and turns into a leaf, it can usually shed its hull, though you can see some hulls are still attached to the seed leaves here. As the plant continues to mature and is exposed to the light, it will start to develop its true leaves and eventually shed the cotyledons. But we usually don't want microgreens to get that mature. Depending on the crop, as true leaves start to form, the plants can get fibrous, bitter, or fuzzy, or take on other characteristics which can reduce its eating quality. So, to review, at maturity, microgreens will have a short stem, the hypocotyl, and the seed leaves are cotyledons, both of which are consumed. The hypocotyl is cut at the base just above the soil level at harvest time. So this is what a germinating microgreen seed looks like and basically summarizes the process that most of your short cycle crops will go through, with some variation. Don't worry, we'll be looking at this in much more detail later. Now, there are a few exceptions to this growth pattern to take note of, notably corn, wheatgrass, and peas. Here you can see the early stages of pea seed germination, which looks very similar to germinating sunflower seeds. But as the germination process continues, you can see here that the seed in fact remains at the soil surface, while the radicle goes down into the soil and the stem or hypocotyl reaches up for the light. And the seed stays at the soil surface as the crop matures. Microgreens are often compared with or differentiated from sprouts. This is likely from the fact that sprouts have been involved in a number of food recalls over the past several decades due to the presence of human pathogens and are considered high-risk foods in many jurisdictions. Microgreens and sprouts have both differences and similarities to note. Let's take a look at a chart here that summarizes things. In terms of a growth cycle, microgreens can be anywhere from 6 to 30 days, where sprouts are typically 3 to 7 days. In terms of growing method, microgreens are grown vertically in a rooting medium, whereas sprouts are generally grown in water. Most microgreens need light at some point in their production process, and only some sprouts need them, and only briefly at that. With microgreens, we're eating the stem and the leaves, whereas with sprouts, we're eating the roots, stems, and leaves. Both have a really good nutrition profile, and both have a really high seed density when they're growing. Microgreens grow in conditions that are cool to hot with high humidity, and sprouts tend to grow in conditions that are cool to warm with high humidity as well. While the comparison between microgreens and sprouts tends to be on their differences, there's two similarities I really want to highlight: their growing environment and the seeding density. So both microgreens and sprouts are grown in cool to warm conditions and high humidity. These are great conditions for crop growth, but are also good conditions for pathogen growth, both plant pathogens and human pathogens. And in terms of seed density, both microgreens and sprouts are grown at high seed density, meaning each seed is usually in contact with another seed. And this can help increase the rate of spread of crop disease and human pathogens, and seeds themselves often act as a vector, bringing disease into your growing system, and as a food source, nourishing pathogens if they're present. These similarities are important to note because they are both factors that contribute to the propagation of human pathogens in growing systems. An additional factor to consider in crop hygiene with microgreens is soil. Soil is an additional pathogen vector that is not a factor with sprouts, so in some cases microgreens could pose more of a human pathogen risk than sprouts. While pathogen outbreaks appear to be more common in sprouts, they do occur in microgreens as well. But don't worry, we'll discuss how to avoid outbreaks in our hygiene and sanitation videos. Food systems in Canada, the United States, and around the world have been shifting significantly over the past several years, and with it, food regulations. But one thing hasn't really changed in many places, and that's the ambiguity surrounding the classification of microgreens. In Canada, microgreens are sometimes classified as sprouts, which are considered a high-risk food product, yet federal and provincial regulations in Canada are still vague on classifying microgreens and what regulations should or should not apply to them. In the United States, under the Food Safety Modernization Act, microgreens are distinct from sprouts, and thus do not require the same standards of hygiene that sprouts do, making them a much more accessible crop to a wide range of growers. It will be important for you to understand what your local and federal regulations are if you're going to venture into microgreens production. But don't worry, we'll be exploring regulations more in other videos to come. So there you have an overview of some of the main characteristics of microgreens. If you're currently growing microgreens, take some time to observe your crops up close to better understand each of their unique characteristics. The better you understand each of your crops, the better you're going to be able to optimize growth and troubleshoot any problems as they arise.